All right, grade 8, we're going to work on lesson 102, growth and decay. And we're looking at sequences, geometric sequences. We have looked at it in various ways. And what the sequence talks about is there's a constant in between the terms. So we're going to look at a growth sequence and we're going to look at a decay sequence. Growth sequences grow, while decay are going down. So if we were to look at this over here, we can see that in order to get from each number to the next number, to get there, we are multiplying by 2. And the same thing here. Oh, sorry, this is supposed to be an 8. We're multiplying by 2, and you can see that every time we multiply by 2, we grow. So our constant here equals 2. So we take the number and we multiply it by 2, right? So the constant ratio is the multiplier from term to term. This here, this sequence that we're looking at here, is a growth sequence. All right, and if we go to the next one, you can see that we have a sequence that is smaller. It's called a decay sequence. Okay, so if we look at these two terms, we can see that if we go from 64 to 128, if we divide those two in half, you'll see that we make it the smallest ratio, it's half. So if we times this one by 1/2, we get to 264. If we times it again by 64 by half, we get to 32. We times 32 by half, we get to 16. We times 16 by 1/2, we get to 8. So you can see the next term in this sequence would be multiplying 8 by a half, and that would get us to 4. That's really what this is. So in order to figure out your growth sequence, you can grab any two numbers. Let's grab 16 and 32. We put 16 over 32, sorry, over the 16, and that'll give us a constant of 2. And the same thing here, we have created that sequence there. So practice set. Let's go through the practice set for the lesson. Talking about a growth sequence. What's the next? Oh, I've typed too fast today. What is the next term in this growth sequence? So in order to find it out, we have to figure out our ratio. Our ratio would be 24 over 16. We can divide both of these by 8 easily, and so we get 3 over 2, or 1.5. So 54 times 3 over 2, that would be easier to do, and I get 27 times 3, and that should give us our next answer, which would be 81. So you have your constant as 3 over 2, and your next term as 81. The next one that they talk about is a decay sequence for B. Figure out, if you can, on your own, what that constant is, and then the next term, and hit pause, and I'll finish it with you. Okay, so first we do is 192 over 256. That actually may not be the best route. Let's try something different just to show you if you can get lower numbers, it's easier to figure out. 108 versus over 144. We know that that could be divided by 12, right? So then you get 9 over 12. We can divide it by 3. Gets us 3/4. So our constant is 3/4. So then we can go 108 times 3/4. And that will equal 108 divided by 4. Let's just do that quickly here. I'm going to do it without the help of the math book. We get 2, and we get 28 left over. We get 27. Same thing, 27 times 3. which gives us, of course, as we figured out, 81. So we have two of the same terms there. So C takes a little bit more thinking because it says that population is declining by 3% per year. So there were 5,000 students in the community this year. How many students will be in the community by 3 years? So that means that next year, 97% will be there. So what's going to happen, we want to figure it out in 3 years. So what I'm going to do is pop up a calculator here, and we're going to punch it into the calculator. So if we're at 5,000 times 0.97 for the first year, that's your constant, remember? So that's what we're at after that's year 1. Year 2, year 3. So if we have to do it to the nearest 100, it says. So we have 4563. We look at the 6, and we say we have to round up. So our answer would be 4,600. So just to summarize, you go 45,000 times 0.97 equals times 0.97 equals times 0.97, and you get an answer of 4,600. So we're looking at roughly 4,600. All right. D throws a little bit of a loop in there. So if you want to take a look at it, before you look at exponentially. Exponentially would be x to the power of a number. I may have given it away when I told you that. But take a look at how that works. So exponentially is going to be slightly different. So we start at 2,000 and we're at 4,000. Really what we've done to get from 2,000 to 4,000 is we've went 2,000 squared gets us to 4,000. That's an exponential growth. And we go from 4,000, we square it, and we're at 16,000. So really our answer is how much longer is it going to take? It's going to be 2 hours to get all of it grown to the 16,000 number. So there is your lesson 102. Work on evens. I'm available on Meet. Some of you are using it very well. Do use it. I'd like to see those math marks stay nice and high. And thanks for